Hello everybody, and welcome to exercise 1 on page 33 of the workbook. We're ready to now look at some examples of taking a vector space and trying to find a basis for it. Okay, and then in these examples we're going to be making use of the general principle that we talked about back on page 29. Okay, so let's read this together. We're going to be working through part A of exercise 1 in this video. So for each of the following, W is a subspace of V, and in each case they'd like us to find a basis for W, okay, and then to say what the dimension of that subspace is. Okay, so in part A, they start us off with the vector space R3 and a subspace W that looks like the span of 3 vectors. Okay, that's exactly the situation that we've been talking about in some of our previous examples. So what it comes down to asking is, do we need all 3 of those vectors to span our subspace, or could we get away with fewer? Could we get rid of some of them? Okay, and answering that question, or kind of the standard way we have of answering that question, is just to form a matrix that has those vectors as its columns. Just make sure that I copied that right. Okay, and then we'll do row operations. And you can either do your row operations by hand or feel free to use a calculator or an app. Again, it's not so much about the row operations as it is the result and interpreting the results. Okay, so if you do that, doing one operation is going to produce 0, 1, 3. Doing another one is going to produce this. Okay, and if you're curious what operations I used there, to get the second row, we took negative 4R1 plus R2, and then to get the third row, we took R1 and added it to R3. We did both of those at once, okay, just to get zeros under the pivot position there. Okay, and then do one more row operation. Okay, and this time we'd like to get a 0 down here, so we can do that by taking 3R2 and adding it to R3. And if you do that, here's what you end up with. Okay, there's our echelon form. And where are the pivot positions? Well, there's the first non-zero entry in the first row, first non-zero entry in the second row, and then we've got no non-zero entries in the third row, so just two pivot positions. And our general principle tells us that means we just need to take the vectors corresponding to these first 2 columns, and that's going to give us a basis. Okay, so therefore, beta equals, okay, vector in the first column looked like 1, 4, negative 1, and the vector in the second column looked like 2, 9, negative 5. That's a basis. Okay, what about the dimension? Okay, well, remember how dimension was defined. The dimension of a vector space is just the number of vectors that it takes to form a basis. So we can answer that question just by counting the vectors in this set beta, noticing that there are 2. That tells us that the dimension of our subspace has to be 2. Okay, and I think we've answered the question.